70, climbing stairs. You are climbing a staircase. It takes n steps to reach the top. Each time you can climb either 1 or 2 steps. In how many distinct ways can you climb the top? I am very excited because this is our first encounter of a dynamic programming problem, and that also means that I've attempted this in class, but it's been probably 2-3 weeks, and all I remember is that it's a dynamic problem and that I don't quite recall the structure of a DP program. I know it's like you build on each iteration and then the final answer is like sum of the last two or something like that. Example 1, input is 2, so if there are 2 stairs, you can take 1 or you can take 2. Input is 3, output is 3. We add the n equals 2, you can do one more step because you can't do 2 steps. Fundamental aspects of a dynamic programming is the base case. If n equals 0, so if n is 1, then it's always going to be 1. And then if n is 2, but starting with n equals 3, it's like n minus 1 plus n, I think, was something like that. DP general formula programming. Basically saving up the answers so that we don't have to compute them again. So I believe we have to set up an array to save that, or a dictionary? But what the heck is DP? Variable name given to a data structure, or isn't it supposed to be like a array? Generic key not found exception. Oh, I forget how this actually looks. Should I look at the hint? Hint. To reach the what could have been your previous steps. I mean, I thought of that. That's what this is saying. I just can't think of how we go from this formula to, yeah, that's the error we got earlier. If we are at 4, it's not here. So, oh, so it's saying that 3n equals 3 doesn't have a solution built in, so it's not able to generate the one for 4. So how do we make it for everything? Do we make a loop? So I don't think we start at 0. We use the ones above and we start 0, 1, 2, 3. Let's go figure it out, I think. I am so happy that I remember this because I haven't visited dynamic programming in a while. But I'm not sure if you're supposed to do the DP of 0, 1 to 3 or 0, 1, 2, or if n is equal to that. Evaluation is 78 out of 100. It is correct and shows DP thinking, but has redundancy and missed optimization. Correct recurrence relation is spot on. Bottom-up DP approach handles edge cases. Redundant early returns. Yeah, I wasn't sure what the right way to do this was. I didn't quite remember. Your top if block and your DP initializations are doing the same job twice. You are setting base cases in 2 places, which signals uncertainty about what the base cases actually are. Pick one. You only need this. The early returns are redundant. Because we know the size up front, space can be reduced to O of 1. Doing this takes care of the 0, 1, 2. Start at 3, plus plus, int current. Passes all cases, correct, defined twice. Slight confusion, dictionary instead of array, O of n when O of 1 is achievable. Your code is O of n, stores every value in a dictionary, n slots in memory. Wait, but if I recall correctly, I thought the whole concept of dynamic programming, like one of its weaknesses is that it does take space. But I guess I'm learning that if we do this magic, we don't have to use unnecessary memory. Because all we're tracking is, those 2 variables. No matter how large n gets, you only ever have exactly 2 variables alive at once. If I were to have 1,000 key value pairs, that's a lot of memory compared to just having these 2. We got the question right, but I didn't quite grasp the base cases correctly. In data structure, I could have used array here, and space complexity therefore could have been O of 1 instead of O of n, and this also, dead code of DP0 could have been taken care of by utilizing this simple line, so it's a lot better memory-wise. Okay. Thanks, Claude. Today we attempted the climbing stairs, which was a pretty big moment in adding a dynamic programming question to our list. I definitely felt rusty, but somehow got to the finish line. It was evident that understanding of the whole concept was still shaky because I'm still relatively new to it. Asking, what exactly is DP here? Completely initially stepping the whole memoization step where you're supposed to save your computations along the way was a little shaky and unsure about how the base cases are supposed to be addressed was definitely awkward. I would say the key concepts I feel like it was not just one thing, it was memoization, base case, and space optimization. That one was new that I learned only through Claude. I was glad that I managed to look at the error code and figure that out. Realized that I was missing the whole table for memoization purpose. That's a nice start to the week. But yeah, don't really have much else to say. So take care. Hope you guys have a great week.